Which edition is this edition? No, it's quite new. 2021 is the latest edition. You have your book?
Yes, ma'am.
I don't know why. Where is it from? Did you understand last time's topic? Manta, we were talking about Manta. What about you, Kaushik? Did you understand? So, today if I ask you some questions, then are you able to write? Yes or no?
Yes,
You
ma'am.
be able to write that? Okay, fine. Now you give me your attendance class. Yeah, let's sign it. So we have understood what is meant by solid state, liquid state, or that you have understood. And there are plenty of examples which are given in the textbook by which you can make out why a certain substance exists in the form of a liquid, okay? And why liquids can be compressed, why are there gases which can be compressed? Why do you think gases can be compressed? Can they be compressed or not? Why? Think of the question. Why can gases be compressed? Can they be compressed or not? Go look at your textbook. Now I've already told you. What compressed? Thank you. Yeah, why can they be compressed?
Compared to solids and liquids.
Yes, compared to solids and liquids. Can gases be compressed? Can easily be compressed. Why?
Because the distance,
Correct. Come on, you tell me.
intermolecular distance.
We can reduce the distance by
By how? By what?
vacuum.
Think again. Suppose I'm having a cylinder.
From high air pressure to low air pressure.
Not high pressure to low pressure. Give me one sentence. Something to do with it. Suppose I'm having a cylinder, okay? And this is your piston. You know what is a piston? Something that can be pushed down. Okay. Suppose I'm having these other gas molecules. What happens if I apply pressure?
The high air pressure will be created.
Yes, the pressure will be more, isn't it?
Yes,
So when I'm going to press it, what is happening? It's just like a pitchkari, right?
Yes,
Like a syringe or a pitchkari. So this thing will come down. So when it is coming down, this is exactly what is going to happen. Okay, so this piston, I have put pressure and it has come down. Right? So what happens to these molecules?
and they compress.
My question is, why can't they be compressed? Don't say it can be compressed. That is there in the sentence itself.
Ma'am, what is an example of cylinder in the side side?
Tell me now. Tell me, you look at the diagram, it is so simple for you to see. Now,
Because we intermolecular space between the air particles and a lot, we can decrease it by this.
yes, so many of it can be compressed by application of pressure. See, the molecules are coming closer, isn't it? Here, what is happening? The molecules are far apart. Okay, they are far apart. So when you're applying pressure, the intermolecular distances are reducing. Therefore, it can be compressed. You said it right. You started your statement correctly. You said intermolecular forces. बाद में क्या हुआ? I don't know whether it is more, whether it is less. Did you understand? You know the answer, but the way you put it down in words makes a lot of difference. Okay? Okay? So what have you done? That by application of pressure. If pressure is more, then what happens? It can be compressed. Okay? Why? Because the distance between these molecules are getting lesser and lesser, it reduces, and therefore what happens? A gas can change into
Liquid or solid.
and liquid. If further you are going to decrease it, then of course it can become a solid. Is that okay? Okay, for example, I'm having oxygen which is present in a gaseous state. If I'm applying pressure, it can become liquid oxygen, maybe even solid, but at very low temperatures, temperature is also going to make a lot of difference. Okay? So if you are having the text, you can refer to it. None of you have it. Okay, so anyway, I'm going to teach you. Can change, can matter change? Okay, so let me just talk about how
How that changes.
yes, can we change the state of a matter by
Yes,
using
ma'am.
pressure? We have seen yes. Okay, we can definitely use pressure and we can change the state of matter. So from a gaseous state, you can come up to liquid state to a gaseous state by application of pressure. Now, how does temperature? One is by using pressure, the other one is by using temperature. Okay. Let's take a simple example and understand. Can I rub this out? You want to take down this diagram so that it becomes okay, and I want you to write in this question also for homework. I want you to write this question and come. Right? Take down. Homework question. Why can gases be compressed? Why can gases be compressed? If you want, you can take down the diagram because it will help you to answer. I've just given only 5 molecules, so you can see when I'm applying pressure, what is happening. The molecules are coming closer, and intermolecular distances are reducing. Therefore, it can be
So when
compressed.
the force also increasing, then
Force means I'm applying force, I'm applying pressure. Pressure
no,
is
the intermolecular force is
intermolecular force of attraction. You have to use the word intermolecular forces of attraction. When it comes, these molecules are coming closer, what is happening? It's getting more and more attracted. So, finished? Now let us see what is happening when I'm going to change the temperature. Suppose I have a piece of ice. Yeah. So suppose I'm going to apply heat, or even if I put it at room temperature, what will happen? It will form water. If I further,
water vapor,
yeah, what will happen?
water vapor.
It is steam or vapor. Correct? So here what is happening? There is a change
Due to temperature.
of state because of temperature. Okay. Now who will answer my question? Why did ice become water when I put in heat? Heat can also be given by this
Yes, ma'am.
small triangle. You know that. Not it. My question is, when I'm heating ice, it is changing into water. Is this a physical change or is it a chemical change? You know that it is a physical change because this is also H2O, this is also H2O, so therefore it is a physical change. Okay? Okay. Now my question, why did this ice become water?
I'm due to heating the distance, the process or the distance have reduced, has reduced.
What distance has reduced?
Huh?
What distance has reduced?
Intermolecular distance of attraction has reduced.
One due to low temperature of
Due
the
to high temperature.
due to low temperature the water flows into ice because like the distance between the intermolecular distance in between.
Okay.
But when we heat the ice, the intermolecular space increase and forms the H2O.
Okay. So intermolecular, what he said was he started off with water and then he said it has become ice. Now if I take ice and if I heat it up, what is happening? Because you're heating it up, the kinetic energy increases. Use the word. What will you use? Heating is increasing the kinetic energy. So if you're heating, what will happen? The molecules are moving apart. So in ice, you are having all these molecules which are very close to each other. When you're heating, what happens? Kinetic energy increases. Okay. And therefore, what happens to the molecules? They are all moving apart, and therefore it becomes a fluid. You remember the word fluid.
Yes,
So I want you to use these words. Kinetic energy, intermolecular forces is decreasing, but the distances are increasing, and therefore it becomes water. Okay, did you understand? Come on, take up. Leave some space for your listening. I'm giving you another question to write. Okay, leave some space for your homework. This is the other one. Okay. Why does ice become water on heating? Okay. So I want you to use some words. What are the words to use? Kinetic energy. Make a note of it. Put it in bracket so that you don't forget. Kinetic energy. We will also talk about intermolecular distances which are increasing. Okay, you know, right? Yeah. Intermolecular distances are increasing.
Due to kinetic energy, the intermolecular distance increases, and therefore
Molecules
ice
are moving
molecules
apart.
are moving apart, and therefore ice melts into water.
Water, and it has fluidity. That also has to be mentioned. So mention the word about fluidity also. Fluidity
Intermolecular distance.
is increasing. No, this distance is increasing. No,
Yes.
and when this distance is increasing, so intermolecular. No molecules can be intermolecular distances are increasing. Is that okay?
Yes.
Right. I'm reading this point from your textbook. This is on page number 7. Right? You have the textbook. I read that on increase in the definition.
No, it is at home. It is at home.
Now it
This
is
is sleeping at home. Your textbook is sleeping at home. It's on page number 7. You might have. Yeah.
by increasing the temperature of solids, the kinetic energy of the particle increases.
Listen, okay, listen very carefully. We'll read it. Read slowly.
Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed position and start moving freely. A stage is reached when the solid melts and is converted to a liquid. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point.
So, what is the melting point of ice? What is the melting point of ice? At what temperature? If I keep ice, when does it
Now,
start?
room temperature.
Room temperature, even if it's below the room temperature also it starts melting. So at what temperature? Melting temperature and boiling temperature of water, you know, at what time or at what temperature does it boil? At least that you know. Water boils
The
at
liquid starts boiling.
what temperature? 100 degrees Celsius. At 100 degrees Celsius, it starts boiling. When does it start melting? Okay, this is something that you must know. If I put a backward arrow here,
0 degree.
it is at 0 degrees. Okay, so your melting point, MP melting point is 0 degrees Celsius. Okay, that means water will get converted into ice at 0 degree. Ice will also turn into water at 0 degree. So what is the definition of melting point? Melting point is a temperature at which there is a change of state from a solid to a liquid. Come on, write down. Melting point, okay, is a temperature.
No, the face.
Melting point is a temperature at which the solid melts into liquid. Now we have not changed anything. At which, what is happening now? Tell me what is happening here. Nisha,
Ice is
Solid is melting into
ice.
now. Ice is melting into water. Okay, so for water, the melting point of course is unzero.
Can you repeat?
Melting, not boiling.
Oh, see.
Boiling is at 100 degrees when it is becoming steam. Now we are talking about melting. That is
Can
at
you
zero.
repeat? Melting point is the temperature.
At which the solid becomes a liquid state. For water, what is the temperature? For water, the melting point NP is 0 degrees Celsius. Okay. Melting point can also be called as freezing point. Why do you keep water in the fridge? So that it becomes ice at what temperature? At 0 degrees. So that is why it's also called as a freezing point. Okay. So melting point for this is of course only for water. For other substances, the melting point will be different. This is only for water that I have. So melting point is also called as
Freezing point.
freezing. You remember? Yes? Okay? Now, here. There's again a change of state. Okay? Suppose I have taken in a beaker, I have taken some water and I'm heating it up. Right? You'll find that it is becoming vapor now. Steam is coming out. At what temperature is this happening? It's boiling.
Boiling.
100.
Boiling. So what is the boiling point? Boiling point, you are going to write it as 100 degrees Celsius. Did you understand? So what is, how will you define boiling point? Come on, you tell me now.
We can.
What is the boiling point? It is 100 degrees. Now you define what is boiling point. Same thing like this. You tell me like this.
BP, that is equal to 100 degrees.
What is it?
100.
What is it?
We-
It is a temperature at
the
which
temperature at which the water becomes water
Water
evaporates and
You know what the
what it means. Is this possible?
Yes, ma'am. Yes.
Okay, that's also possible. So boiling is also taking place at 100 degrees, but condensation is also taking place. That means the vapors are condensing to form liquid water. This is also taking place at 100 degrees Celsius. Okay, so don't get confused. Vaporization and condensation, it is going to be the same. Right? Clear? Right? Now, on the same basis, can you tell why it is becoming into a vapor? Once again, you're supplying heat, kinetic energy is more, therefore those bonds are getting broken down, particles are moving apart. Now it has become a gas. So gas, the molecules are so far away. Did you get it? Understood now how to write down the answer? You know the answer, but you have to learn to write it down. No mugging up. You have to learn to express it in your words. Is that okay? Fine. So now we have completed the melting point of a solid is an indication of the strength of the force of attraction between the particles. So for example, if I say solid iron, okay, iron melting point will be very, very high. Okay, it melts at a very high temperature. Yes. So we have got, it shows that these molecules are really attracted to each other. It is so strong, the bonds which are holding up very strong. So the higher the melting point, what does it show? It shows the strength or the forces of attraction. Okay, the greater the forces of attraction, the greater is the melting point. Are you clear about it now? Yeah, clear? Okay, fine. Okay. We are also going to talk about something which is known as latent heat. Now with this idea here, yeah. Tell me.
What do you just say?
Latent heat. I'll write it down. Latent heat. Suppose you are taking a beaker of water. Okay, you are having a thermometer. Okay, this is your thermometer, right? And you're constantly heating. What will happen to the temperature?
Temperature rise.
Obviously, the temperature keeps on rising 25, 35, whatever, till it comes to which temperature? Why through temperature? I'm still heating.
Ma'am, because if you are still heating it, but temperature in the container is just till that only. The water
Now I'll come to this state. When I come to this state, what will be the temperature here?
100 degree.
At 100 degree, what is happening?
Ma'am,
The
the water is
water
boiling.
is boiling, and at the same time, the steam is also forming. Okay, so at 100 degrees, what is the state of water? Tell me now.
The state of the water, water changing into water.
What is the state of water?
Gas.
Is it gas
Gas.
or is it liquid?
Gas.
Yes. But the temperature here is still the liquid.
And you
Liquid is
said-
also boiling. So here temperature is showing as 100 degrees. At the same time, you'll find that steam is coming out. Okay. So at 100 degrees, water can exist as a liquid and as a gaseous state. Both the states is present. Till what? Till the whole thing has disappeared. Okay. Once it shows 100 degrees centigrade, okay, till that entire water begins to change over into a liquid state, the temperature will not rise. It stays constant at 100. That's why it's called latent. Latent means what? Hidden. So what is happening here? Why is it hidden? Why is the temperature not beginning to rise? That's because the heat which is getting absorbed by the water is helping to break the bonds and these molecules are moving apart. Did you understand? No concept is clear. If I'm going to show it to you in the form of a graph. Okay. So let us say I have started at 25, that's 50, that is 100. Okay. So I'm starting with, let us say, 25 degrees and I'm heating it up. So I'm heating it up like that. So what will happen? It will keep on coming to 100. At 100, what will happen?
And it will stop and steam will start coming from the water.
Okay. Okay, so for some time you'll find that the temperature will remain at 100. It will not go 100, 500, can go. When? Till the entire water has completely changed over into steam. Did you understand? So this temperature is what is called as a latent heat. Did you understand that clearly? Okay? Come on, write down. Write it down. Latent heat. Okay? Latent means hidden. Okay? The heat, come on, the heat is getting used to change the state from liquid to gaseous state.
Change the state from liquid to
From liquid to gaseous state. Yeah. By overcoming
From liquid
to what? Which state?
gaseous.
overcoming the intermolecular
Yes, of attraction.
force of
Yes, by overcoming the forces of attraction between the particles of the
And overcoming.
by overcoming the forces of attraction. By overcoming the forces of attraction between the particles. Did you understand now? Okay. Now tell me one more thing. When you're putting it for boiling, are only these molecules undergoing a change or all the molecules?
All
which
the
are-
molecules.
Yes. So this is known as a bulk phenomena. Bulk. Bulk means all the molecules. But for evaporation, what is happening? Suppose you're having water in a dish, it's only the water molecules on the surface. Only on the surface they are getting
And the
evaporated.
whole plate you gets evaporated.
After some time, but gradually what happens? Suppose this is a dish that you have taken.
And
Okay?
first the most bottom layer starts evaporating where the heat
Only the outermost. So these are the particles. These are the particles that begin to change. Okay, not these particles. So layer by layer.
and the heat at the bottom heats up and then this bottom does heat.
I'm not heating. This is evaporation. Don't get confused. Here I'm showing evaporation. Okay? Because evaporation is another thing that we are going to start. So I just showed you the difference between boiling. Here what you said was right. When you're heating from the bottom, these molecules are getting heated up, so they move up, and because of convection currents, that is how it begins to. Okay. Here, what is happening? Okay, this is evaporation, so that is a different thing. Are you okay till now? Okay, here. Okay, now I'm asking if you need here. Read this paragraph. You have that in your book, isn't it? In your show me that. Yeah, you must have observed.
You must have observed during the experiment of melting that the temperature of the system does not change after the melting point is reached with all the ice melts. This happens even though we continue to heat the beaker. That is, we continue to supply the heat. This heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature. It is considered that it gets hidden into the contents of the beaker and is known as the latent state. The word latent means hidden. The amount of heat energy that is required to bring 1 kilo of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. So particles in water 0 degrees Celsius have more energy as compared to particles in the ice at the same temperature.
Did you understand now what is happening? This is ice. Okay, imagine this is ice. Ice is at 0 degree. Okay, now if I'm allowing it to stay here, it is becoming water. But the moment it changes into water, the water is also at 0 degree.
But it can't have more particles.
Same particle. Number
More
of
energy,
particles.
more energy.
Why? Because it is absorbing heat from the surrounding.
Solids have like,
I'm talking about ice now.
ice and solids. Ice, like example of solids. So they have those intermolecular distances, like very intermolecular forces is very strong, very strong. So ma'am, the energy is more compared to water.
Which energy is more? You are talking about the energy of the water. Will definitely be more as when compared to ice. Why? Because now it has absorbed heat. By absorbing heat, the particles are having more energy. Therefore, water which is at 0 degree will have more energy as compared to this. That's all. Because obviously it is capable of moving. But have we supplied heat? What has happened to that heat? That is what is known as latent heat. Okay, because that heat which has taken in, it is called as latent heat because it has got conversion from a solid state to liquid. Now, same thing here also. If you have understood this particular phenomena, the same thing is happening here. Okay, steam and water. When it starts boiling, it is at 100 degrees. Okay, but this water has changed over into steam at 100 degrees. Why? Because it has absorbed and these particles have started moving apart. So this temperature at which it is changing over will remain constant for some time. And this is what is known as latent heat of evaporation.
Vaporization.
Okay, vaporization, evaporation, it is the same. Did you see that? Okay, so that is your latent heat. And therefore we know that latent heat, that is heat, steam, injuries which are caused by steam is much more as when compared to the injuries which are caused by 100 degrees of water. Did you get it? Okay, so because it has taken up more heat and that heat is actually hidden and that is what is known as latent, right? So you see here, right? And another thing that I'd like you to understand is whenever we are talking in terms of Celsius, okay? Now most of the time when we talk about SI units, SI is what? System International. What happens is each of the countries, they have Fahrenheit, okay, they have got a British system, we have got a centigrade system. So all the countries of the world have decided that, yeah, we are going to use a System International. That is called as an SI unit. Now for temperature, basically we are using K. You know what is K?
Kelvin.
Kelvin, right? So this is your Kelvin temperature. For example, if I want to convert
373, 100 plus 272,
Yes.
which is
Okay.
273,
yes, 273.
which is 0 degrees.
Yes, so that is it. So whenever you want to convert degrees Celsius and you want to write it in terms of Kelvin, we have to add 273. Can you understand that?
To add
And 273. Suppose 0 degrees Celsius plus 273. That is equal to 273 K. So what is 0 degree?
273.
Is 273 K. Did you understand? Suppose I say 25 degrees Celsius. What should I do? Plus 273. Okay, so how much is that? 892. Okay, so it is 298. Okay, did you understand? Suppose I give you this temperature and I want you to convert it to degrees Celsius. What will I do? Minus 272. Okay, so if you look at your textbook behind, there are
100.
273. 273.
100 is a
Boiling point in degrees Celsius. Degrees Celsius. Now suppose I am giving you 298 K. I want you to convert it into degrees Celsius. What will you do? Will you plus it or
Minus.
You have to minus. Minus what? Minus 273. So your answer will be incorrect. Got it? Understood? Okay. So there are a couple of questions if you keep in mind regarding how you have to see. They are given 300K, 573K, right? What is the physical state of water? All these things are given. Is that okay? Clear till now? Okay. Unfortunately, people don't have this text. I am referring this text. You are having that. You have it at home. You get it now. When are you going to buy? You are having it at home. Then you get it. This handbook is going to be very useful for you to learn up. But when I'm teaching you, you must know at which part of the textbook. All of you should get into the habit of reading the textbook. You read it or no? You read? Yes. What about your question? You read your textbook? Yes. All that is done. This diagram also they have given, which I have already put it up. Outer solid is changing into liquid state. Liquid is changing into a gaseous state. All that I have explained to you today. Right? Now there is another interesting phenomena which is called as sublimation. Are you familiar with sublimation? Have you seen camphor?
Yes, ma'am.
What is camphor? Or even you have, what is that, odor type, which we keep it in the cupboard. It gives a nice fragrance and it prevents
No, it's
disease.
not like actual camphor, it's mixed with something.
Obviously, it is mixed with something. So this one feels like camphor, ammonium chloride. What happens is, instead of going through this stage, most of the substances go through this stage. But some of the substances directly go from solid directly to a gaseous phase without going through a liquid state. For example, camphor. Okay, suppose you keep it out, you find that after some days it's not there at all.
But incense,
Incense stick is different. Incense stick is agarbatti.
even though we treat it out directly, and it directly goes into ashes.
Yeah, because some ash is also formed. And it's a mixture of something else. Okay, of course, liquid phase is not present, that is true. But some residue, some ash is also there. Here we are talking about a pure substance, like camphor, ammonium chloride. So this is ammonium chloride. And this is a very interesting experiment. See this experiment with a conical funnel. Is it given in your book? So what are we doing? We are taking a dish, and in this dish, I am taking some ammonium chloride. Okay, and I am putting one conical, inverted conical funnel. Okay, so I'm the whole thing. I'm going to keep it on a wire gauze. This is your wire gauze, and of course, I'm going to heat it up by using a Bunsen burner. This is on a stand so that it doesn't fall down. Okay. Most important thing is you have to plug in. You have to put some cotton or something of that sort so that the vapors do not escape. So when you start heating it, what do you follow? What do you see? You find that there are white fumes coming. Okay. Ammonium chloride itself is a white color solid. It's a white color solid. So when you heat it, you find white fumes which are coming here. So after some white fumes. You can actually see it's like smoke, white smoke. Okay, so we are going to just switch off this burner, which means to say after some time what will happen? The entire thing will cool down.
Ammonium chloride directly changes into
Yes.
gas without forming,
Without going into
without
the
even going into liquid state.
So what is this process called? What is it called? Sublimation. What is it called?
Sublimation.
Sublimation. Okay? Okay? Come on, write down. Sublimation. When a solid changes to a gaseous state, I should write. Okay, when a solid state changes into a gaseous state without changing into a liquid state.
Changing into a,
Think and write. See what you have written.
when a solid state changes into a gaseous state.
Changes into a gaseous state without going into a liquid state. This process is called sublimation. It's called sublimation. Okay, what is the example?
Ammonium chloride.
Yes, right on there. Example, ammonium chloride. Write down the formula so you slowly start learning the formulas. NH4Cl. Nishad, did you write? NH4Cl. That is your ammonium chloride. Ammonium chloride. Okay. The other one. Other example is camphor. Write down camphor also.
NH4.
Cl.
Cl.
Camphor is another example.
No chemical.
It's a very big one. It's an organic compound. So that you just keep it like that. Okay. Is that okay? Now I'm asking you a question. He said that by heating, it directly goes into a gaseous phase without coming into a liquid phase. Is this possible?
Yes,
What
ma'am.
happens if I cool it now? Will it become liquid and then it will become solid? No.
It becomes solid.
Same thing. Okay, so the reverse process is also true. Okay, sublimation is also a process when a gaseous form or a gaseous state changes into a solid phase without going through a liquid state. Okay, so that sentence that I have given you in bracket like that, or vice versa. Or vice versa. Okay, even the reverse process. Just keep that right here. Okay, clear? No? So what happens if I, so you have understood the process of sublimation, right? Will you remember this experiment?
Yes,
It
ma'am.
is given in your textbook, but I don't know whether it's there.
Yes, ma'am. It's given. Same page number 8.
I know it's given in the textbook. For them, I don't know whether it is this experiment. This is what I have explained to you.
I have
That book it is not given. Yeah, so that's why you get your textbooks from next time. I told you. It is not there, I know. I'm referring to the textbook and you should get the textbook, right? I've also told you regarding what happens when you're applying pressure. Okay. When you're applying pressure on a solid, as when compared to application of, yeah. Up to a certain extent, maybe it can take up some pressure, but if you start hammering it or anything of that sort, obviously it's going to be pieces.
Even like you told us about applying pressure in a gas, it directly changes it into a solid state. So answer.
No, into a liquid state and then it goes into a solid state. Most of the substances. Okay, most of the substances, if you are having a gaseous state and if you are applying pressure, comes into the liquid state and then of course it comes into a solid state. So that is a normal step that is happening. Okay, so there is another diagram which they have given. How you have got a piston, a cylinder is being applied, keep on increasing, okay, the pressure, obviously turns into an acid. Now I'm asking you a question. Right? Who will answer? Answer, okay? How all of you can go for swimming, you learn swimming.
Yes.
Understand? Why can you swim? You can swim in water.
Yes.
Can you swim on solid? Why?
Because
Because of that.
Okay, that is right. That is right.
intermolecular distances
Intermolecular distances of what?
force, intermolecular force is high.
Where?
Or
You are talking about solid or you are talking about water?
solid.
Oh, okay. In solid,
So the intermolecular distances are very close to each other. So that's why we can't swim.
why can you swim in water then?
Because the intermolecular distance is very long. Far from all.
Okay, then you know.
First point is second point.
You tell me properly. Let me say. My question is, a person can swim in water. Why?
We can swim in water because like the intermolecular space between particles of water are far off. So the particle can easily move inside water. And second one is water is cold. So it can change the shape if we go into it.
Anything else? No, I'm not talking anything about pressure. You are still on the earth, on the surface of the earth. Nobody is increasing the pressure or anything about it. A person can swim in water. Now you talked about the molecular distances. Think in terms of forces. Also, one more point you can add.
Intermolecular force.
No point force. I mean, point force. Yeah, listen. Yeah, I am. We're not talking about point forces. Yeah.
Intermolecular force in liquid is weaker.
Us. Okay. Yeah. We are talking only about states of matter here. We are not talking much about atmospheric pressure. We are not talking about point forces. All those things are definitely there. But now what are we doing? We are comparing the three states of matter. Okay. So there is another interesting question here. I don't know, sir, it's okay. I'm gonna take down this. You can write down one more question, right? See, on page number 6, there's a question, right? That's your question number 3. Write it down, all of you, right? Page number 6, and question number 6, give reason, okay? We can easily move a hand in air, but to do the same through a solid block of wood, we need a karate expert.
Molecular force of attraction.
Same thing you have to write. Okay, whatever they give you,
Can you
yeah, write down question number 3D. Question number 3D. Okay? Okay, Nisha. Now I'm asking you, you can move your hand in air. Can you move your hand in on solid? You can move. You can't move. Why? That is the question that they've asked.
Can I just write the answer? Can I just write the answer?
You want to write the answer? Think about it. Now I need to discuss a few more questions here.
can you repeat the question?
You will read the question from your textbook. That's for your homework. Which question is it? Question number
Question number 6, give reason. Question number
3D. Bas. Sanjay, how will you answer it now? You can move your hand in same thing. How can you swim in water? We have discussed. Same thing here.
And you can move your hand easily in air, but to do the same through a solid block of wood with a karate expert, as the intermolecular distance of attraction in solid is more than compared to water.
Air. We are comparing air and solids, na?
And
So no need for you to compare it. First you talk about air, how the molecules are in air. Okay? See in solid, how the molecules are. And compare. Samjha? Here, will you be able to do that?
Yes, ma'am.
Okay, fine. Okay. And another question, you write it down. What is the, come on, take it down. What is the state of water? That is what they have given.
the
State,
physical state of
yes, physical state of water.
what does it mean?
Physical state is what? Water exists in three states, solid, liquid, or gas. At 250 degrees Celsius, what is the physical state of water?
Gas is at 100 degree it boils, and 50 degree is boiling.
Okay? Okay? So at 250 degrees, what will you write? The physical state of water is a gas. That's all.
And at 100 degrees Celsius, it would be both gas and liquid.
At, okay, at 100 degrees Celsius, what is the state of water?
Both gas and liquid.
Yes, liquid is there and also it is in a gaseous. And I think there are a good number of questions that they have given you here.
Yes,
This is all for your homework. You have to practice now. Because you have almost now see, this is your second class now. Right? So now you are quite okay. It's your second class. Now you are quite okay with different concepts like boiling. And proceed.
And in this also the diagram is there.
Yes, they have given here, see,
Sublimation.
sublimation, they have given here. They have given that. This is what we have done. So NCRT questions are also given here. See, NCRT questions are given and all the answers they have given. Okay, so this is what you're going to do. Okay, one or two more questions I will ask you. Let's see if you practice. Okay. I want you to understand the concept of latent heat. Did you understand the concept of latent heat? Okay, there's a question here. For any substance, why does the temperature remain constant during a change of state? During a change of state. Okay, like for example, we have already seen you have taken a container, you're heating it at 100 degrees Celsius. At 100 degrees, water is also boiling, gas is also coming out. But the temperature is not increasing. Did you get it? So what I, yes, then.
And because the object which is getting heated is absorbing heat to break the bonds between the break the bonds of the intermolecular distance.
No,
No,
to break the
intermolecular
bonds between the molecules, that's it. That's all. That is the most important. Okay, because they have to overcome it. These bonds are holding it, no? So you're supplying energy, you're supplying kinetic energy so that it overcomes it. And that is why the temperature remains constant. Till what? When the change of state is taking place. After the change of state, then of course the temperature will increase. Samjha? Here? Here? Right. Then I want you to write down this one point concept. See your latent, let me see in your book, what book? Latent heat is there, you see? You see and tell me? See?
Yes, latent heat,
Latent heat, which page is there?
3.
Page number 3, put a tick mark. There? Where is it given?
Latent heat of evaporation.
Yes. Yes, so put a tick mark here, see? Here also, latent heat of vaporization, boiling point, what is latent heat of fusion? Okay?
Sublimation.
Sublimation, no, I have not yet done. Sublimation, of course, yeah, ammonium chloride we have done. Isn't it? Sublimation.
Vaporization.
Yes, vaporization we have done. All these effect of
And
heat.
fusion is not there.
Fusion is the same thing, no? Melting and fusion, I said it is the same thing. When, see here, solid is at 0 degrees. Okay, this is ice. It is melting.
Water.
Okay, it is becoming water, liquid water. This is called melting point. Also called fusion.
What is diffusion and osmosis?
Sorry?
Diffusion and osmosis.
All those are two different concepts.
No, ma'am. Like it started today. We started in biology, and ma'am told us ask your chemistry teacher what is diffusion and osmosis. I was like, ma'am, chemistry teacher is like still checking pens, board papers. Like it came in and I asked.
Diffusion is basically when we are talking about, let us say, I said perfume. Suppose you are putting perfume, or somebody is lighting some other burning one. Immediately here, you can smell it. Why? It's a gaseous state, and gases are in a state of fluidity. You can move. Okay, intermolecular forces are very weak, so आराम से जाएगा. Okay, so that is basically
Even those hypertonic and hypertonic solutions.
isotonic solutions.
Hypertonic, hypertonic.
That's biology, but part of it because he's asking in chemistry, I told you. Okay, so that basically that is what is meant.
Teacher told that chemistry and bio are mixed.
Not only that, even physics,
Exercise.
and chemistry, that is also overlapping. That's why we talk in terms of biochemistry. You know, so much of physics is happening in our human body. Yeah? No? Heart pumping. So much of pleasure.
Contraction and
When you say BP for a person, basically we are measuring the pressure.
pressure of the blood.
So tell me now, if I'm making gas in a balloon, okay, I'm taking a balloon and I'm putting gas. Nisha, are you listening? Okay. Will it have pressure? I'm taking a rubber balloon, okay, and I'm blowing. I'm blowing air into it. Will the balloon have pressure?
Yes.
Right.
And it was giving a balloon before was vacuum and it
And because of application of pressure by the outer covering on the outer wall.
So no, scientists, all of you have this. Varna, you have to put it in. How will you do? You have either that machine to do it, or maybe you go outside and fill it up. Will it be under pressure? You are doing air.
the outer covering is stretching.
Okay, good. What are you filling in?
And
So what is happening? Air will sit in one place.
air will freely move around.
Then what is happening?
And the air
Freely
will
move around and then do what? What is happening to air
increase the
molecules?
size.
So you have the container, whatever it is. It may be a balloon or a container, and these are the air molecules. Okay? Will they remain like that?
No,
What's happening?
and they will just like flow.
Move, and then what is happening? It's also striking the walls of the container.
Ma'am, I said it. Ma'am, it's just like the outer wall is creating the pressure inside for the gas.
Water wall is not creating
The inner
pressure.
wall.
These molecules which are present will go and strike against the walls of the container. Okay, he come and hit and come back again. These are all elastic motions, and that is basically what is causing the pressure.
Pressure. Ma'am, like it is when we blow air in the balloon, the water, like gas or the air just strikes the inner layer actually of the balloon.
Okay. It strikes the inner surface of the balloon or the container.
Which creates pressure.
Yeah, so that is what is causing pressure. Is that okay? Did you get it? Okay, fine. So let me see if there's any other point on this. Now I want you to read thoroughly from your textbook and your, right?
Yes, ma'am.
Next time I'll be talking about factors which are helpful for evaporation.
Shall I leave it? Factors that are important for evaporation.
Evaporation. Why does, what causes evaporation is basically what Do your homework.
Yes.
Okay, Disha? Ashik, okay? You have any other class?
Maths.
Yes. Bye. Thank you.
इसने इधर अंदर इधर नहीं अंदर अभिषेक
हाँ,
ना क्या करना
अभिषेक मैथ्स का वैसे किया
किसने साइन कर दो